Friends, today we know that our universe is expanding, with galaxies moving away from each other. But if we look closer, we find that in its early days, our universe was hotter, denser, more energetic, and full of radiation. If we go further back in time, we eventually reach a hot and dense point where the matter and energy of our entire universe were compressed. This infinitely dense and small point is known as a singularity, a place where our physics, describing space, time, matter, and energy, breaks down. Interestingly, we also see a singularity at the center of a black hole. This is where the matter and energy swallowed by the black hole get compressed into an infinitely small and dense point. In the entire universe, we see singularity in these two instances, and in both cases, our laws of physics break. The interesting thing is that both these types of singularities are mathematically similar. Due to this, many scientists believe that the Big Bang could be nothing but the singularity of a giant black hole. Stephen Hawking also believed that every new black hole formed in this universe gives birth to a new baby universe. But this new universe can only be accessed by those observers who are present inside the event horizon of that black hole. So, does our universe also exist inside a giant black hole? Are we really living inside a black hole? In today's episode, we will explore this mind-boggling possibility and try to answer this question. Let's start by examining the similarities between a black hole and our universe that lead some scientists to believe our universe could exist inside a black hole. Let's first talk about black holes. If you are a regular viewer of our channel, you will know what a black hole is and how it is formed. For the newcomers, a black hole is formed when the core of a massive star collapses under the effect of its own gravity, shrinking into a very small point. This causes the gravity of the black hole to become so powerful that no object, not even light, can escape it. The event horizon is the boundary of a black hole. Once an object crosses it, it can never return. As a black hole swallows the matter coming towards it, the size of its event horizon also increases. A black hole consumes matter rapidly at first, causing its event horizon to expand quickly. As the consumption of matter slows, the growth rate of the event horizon also slows. If we look at our universe, we find that after the first trillionth of a second following the Big Bang, our universe expanded faster than the speed of light, and over time, its expansion rate decreased. Doesn't this behavior of the universe match that of the event horizon of a black hole? So, is it possible that our universe is the event horizon of a black hole in another universe? Before jumping to conclusions, let me tell you it is not so simple. The event horizons in the three-dimensional black holes in our universe are two-dimensional. This means our universe can be the event horizon of a black hole in another universe only if both the parent universe and the black hole in it are four-dimensional. This theory is a bit strange, but since we do not know much about higher dimensions, we cannot say for sure that it is wrong. But if it is correct, it means that every new black hole formed in our universe will give birth to a new two-dimensional universe. To know whether our universe is inside a black hole, we need to determine whether we can treat it like a black hole. Let's see. If we combine everything in our universe right now, normal matter, neutrinos, dark matter, dark energy, photons, gravitational waves, etc., into one place and use Einstein's famous equation E equals mc squared, we can find their accurate mass. What will happen if we compress this mass into a single point? The same thing happens as with any large mass or energy compressed into a single point. A black hole is formed. But the question arises, what will be the size of the event horizon of this black hole? We can find this using the Schwarzschild radius formula. When we calculate, we find that the radius of a black hole whose mass equals all the matter in our universe is around 46 billion light-years. That is, the event horizon of such a black hole will be 46 billion light-years across. If you have seen the video on the size of our observed universe, you will know that we can see objects up to about 46.5 billion light-years away in every direction. We will never be able to see objects beyond that because the space there is moving away from us faster than the speed of light. That is why we call it the cosmological event horizon. Even if we are inside a black hole, we will not be able to see beyond the event horizon. In a way, our universe operates similarly to the event horizon of a black hole. Is this just a coincidence, or does our universe really exist inside a black hole? We know that our universe was formed by the Big Bang, but we do not know for sure why the Big Bang happened. Black holes might be the answer to this. We know that all the matter swallowed by a black hole gets compressed into a very small space, forming a singularity. But many scientists believe that singularity has a limit beyond which it cannot contain more matter. When the singularity of a black hole reaches this condition, a Big Bang occurs, giving birth to a new baby universe. If this theory is correct, it means that all the black holes in our universe are preparing to give birth to new baby universes. So, is our universe a baby universe created by a black hole in some grand universe? Let's try to find the answer. So far, we have said that our laws of physics break down in the singularity of both the Big Bang and a black hole. But do you know what this singularity actually is? Let's understand it now. You might have heard that singularity is a very small point where the density of matter is infinite. But it is almost impossible for any place with infinite density to exist in reality. What I mean is that no such thing as singularity exists in the universe. We use the term singularity or infinite density because when we try to see what is happening in such a scenario through mathematical equations, our math breaks down. It's like trying to solve an equation and getting infinity as the answer. As mentioned earlier, our math breaks down in two scenarios. At the center of a black hole, where the matter and energy swallowed by the black hole are compressed so much that our math cannot go beyond that, and in the early universe when our entire universe was compressed into a very small volume with such high density that our math cannot go beyond that. So, whether it's the center of a black hole or the inception point of the Big Bang, both are called singularities because our math stops there. Although it might seem that the singularities of black holes and the Big Bang are the same, they are very different from each other. For this reason, most scientists believe our universe does not exist inside a black hole. Let's examine how these two types of singularities differ. First, the singularity of the Big Bang is in the past because our universe started about 14 billion years ago. In contrast, the singularity of a black hole lies in the future because after crossing the event horizon, an object can reach the singularity only in the future. The second and biggest difference is that the singularity of a black hole forms somewhere in space, whereas the singularity of the Big Bang is the entire space. This means the singularity of the Big Bang contains the entire universe within itself, whereas a black hole exists in some part of the universe. A black hole singularity exists at a single point in space, which can be noted as space equal to zero. In contrast, the singularity of the Big Bang must be noted as time equal to zero because time also began from it. However, many scientists believe this is not a significant difference. They say a black hole wraps space-time so much that inside it, space and time switch roles. That is, inside a black hole, space turns into time and time into space. This means that for observers outside a black hole, the singularity that was present in space equal to zero would be experienced by observers inside the black hole as time equal to zero. Therefore, if a universe is created inside a black hole, observers in it will find it the same as we find the Big Bang. They will also feel that time in their universe began from their Big Bang. Many people reject this theory because our universe is expanding today. They believe that if our universe were inside a black hole, it would be shrinking rather than expanding, moving towards the singularity. They find this behavior more similar to a white hole than a black hole. A white hole is basically the exact opposite of a black hole, or you could say it is the time reverse version of a black hole. Its singularity leads to the past, like our Big Bang singularity, and instead of pulling matter towards itself, it expels matter away. But according to the Friedman, Lemaitre, Robertson, Walker, FRW model, our universe cannot exist inside a white hole. This is because theoretical white holes cannot exist in this universe as they violate the second law of thermodynamics. Even if they exist somewhere in nature, our universe cannot exist inside them. We will explore why this is so in another episode. Friends, that's all for today's episode. What do you think? Does our universe exist inside a black hole? Let us know in the comments. If you liked the video, please like it. If you are new to this channel, don't forget to subscribe. I'll see you soon in the next video. Goodbye for now.